Well, welcome everyone. First of all, thank you for coming. If you don't know me, my name is Casey. I'm an undergraduate here at the Department of Education and Outreach. Today we are welcoming Bree Doering. She is from the University of Michigan and is a doctoral candidate in anthropology. Her research is focused on northern Athabascan history, as you can see, in Central Africa and the Yukon, with a particular focus on the late Holocene subsidence changes. She has conducted extensive fieldwork in Alaska and around the world, as well as conducting geochemical and isotopic studies on the soil in order to make inferences about prehistoric diet and GIS analyses that yield important data on settlement patterning in Alaska. So let's give her a warm welcome.
Thank you so much for having me, for inviting me to come. Thank you so much to Jason for inviting me, and to Karina for helping set this up, and for Casey for that really nice introduction. Yeah, so today I'm going to share with you basically the fruits of my dissertation research. This is one of the first times that I'm presenting these data, so I'm really excited for any feedback that you have after watching it. And I haven't had the opportunity to share these data with very many environmental scientists before, so I really value your perspective on this as well. So yeah, this is basically I'm going to evaluate the environment's effect on the Athabascan migration. So let's get situated, if I can. Get situated, sorry. Maybe not.
Is it on? There's a little switch on the side.
I had a battery thing, and maybe it might also just be that I haven't clicked on it. Okay, so where are we going? First, I'm going to tell you a little bit about the sort of theoretical background, the social theory that I'm using to kind of break down a lot of the behavioral patterns that we see in this region. I'm going to talk to you about what the migration event that I'm studying is, where it is, when it happened, all of those key important details. And then I'm going to share with you some of the data that I collected to respond to this question: why did this migration happen, and what was the environment's influence on those human behaviors, before kind of coming to a broader conclusion about how we can think about environmental and social pressures on human adaptive choices in the past. So my research really is focused on thinking about coupled human environment systems. How do humans respond to environmental change and affect their own environments? And how do those environments kind of shape the direction of human behavior? I'm also really excited to talk about migration, because it's not only an important part of our history as humans, you know, migrating out of Africa so many millions of years ago, but also it's a really important part of our history today. When you turn on the TV today, you're faced with all of these news stories about people moving from one place to another, and trying to think about the role of the environment as well as other social processes in those ultimate movement events is really important. So now that I've kind of covered all of that big picture background, these and there's many other photos of Alaska that I took during my fieldwork that you'll see today, and I'm happy to answer any questions about that at the end. But yeah, let's carry along. Who are the Athabascans and where are they? So this is a map of my research area. The orange and yellow dots you can see here are all of the archaeological sites that I'll be considering. But before I begin, you might be wondering, who are these people? So Athabascans are people who speak a Na-Dene language family, basically, and they live today in Central Alaska and Central Yukon. And Na-Dene speakers are also basically within the language family of Navajo and Apachean peoples, which you might be familiar with from the American Southwest and the Great Plains. So essentially, the Athabascans are a group of northern people who live here and also throughout the western US. Another thing that I want to point out to you about this map before we keep going are these darker and lighter gray areas. So these represent two different ecological zones that have been basically mapped out and seem to be fairly consistent for at least the last 5,000 to 6,000 years. And here in this upland ecological zone, it's a very healthy tundra ecosystem that supports a lot of caribou and other upland fauna and flora. And then the lighter gray areas are more of a marshy, polluted area that supports a wealth of fish, also supports moose and other sort of more lowland considered species. And these ecological zones have been used really fruitfully by archaeologists who study earlier periods in this region's history, but not as much at the later period that I'm considering here today. So that brings us to, where did the Athabascans go and what am I talking about? So there's a big behavioral transition that takes place in this region between 2,000 and 1,000 years ago. So those are the dates that I really want to lock in on today. I know archaeologists are always talking about time and past, and it's really important to consider these, contextualize these things that happened in the past, but I know sometimes it can be challenging to keep track of the different dates. So there's a big behavioral transition, which I'm going to be talking about for most of today, which occurred between 2,000 and 1,000 years ago. It seems to have led up to a migration event that happened around 1,000 years ago. And you remember how I talked about Navajo and Apachean peoples? Well, genetic and linguistic evidence suggests that they came all the way from central Alaska and central Yukon around 1,000 years ago. So this is a really big move. And not only was that a really big move, it was a really big move after thousands of years of cultural and behavioral consistency in this region. So we know, based on Athabascan place name data, that people were here in the last glaciation because of the way that people refer to things on the landscape. The Athabascans had been here for at least 10,000 years. And so for some of them to not only pick up and change their behavior, but to pick up and move 5,000 kilometers is a really big deal and demands a little bit of further thought and explanation, which is what I'm going to do here. So why? Why would you do this? So today when I'm thinking about migration, and I kind of alluded to this already, migration is not something that you decide to do lightly, right? Migration is a big choice. When we decide to move from one place to another, when we decide to move into a new house, it's usually the result of many more decisions that were made, and maybe we tried to mitigate the factors that were propelling us to move or pulling us to move in the first place. So as I mentioned, there's a big behavioral transition that occurs around the time of the migration, in fact, just before it. So by looking at the factors that propelled people to adapt in the first place, those sort of preceding behavioral changes, we can actually look at the ultimate migration event. So by looking at the penultimate decisions and penultimate sort of adaptive process, we can actually therefore infer what happened through the migration itself. So I'm giving us a lot of space and time because archaeologists have a really hard time talking about migration in the past, especially in places like this, where there's no written record. We have oral histories, and those are very valuable in thinking about some of the potential social and environmental causes for the migration, but they're not very well anchored in time. And so thinking more in space. So thinking more about these sort of theoretical proxies we can use to apply to explaining this migration event is really where my research comes in. And again, it's really valuable to think about migration in this kind of an environment, even when there's no historic record, because there are so many different things we can learn from the decisions that people made at this time. So, behavioral transition, what changed? The first major change is a switch from a relatively narrow diet focused on caribou. So Athabascans pursued a really successful upland hunting strategy to one that was much broader and included an array of fish. So you can remember I talked a little bit about uplands and lowlands. I'm going to be talking about that a lot more. So it seems that people are using the landscape differently around this 1,000 to 2,000 year ago time period. The second thing that changed that was really significant is a change in mobility. So I mentioned a migration, that's also mobility. But in addition to that, people changed from being very nomadic to being what we call semi-sedentary. So basically a little bit more stable, a little bit more consistently reoccupying different places on the landscape and building villages, building storage features like this one you see here. This is a storage rack. Using pottery, which is again another technology that's associated with a more settled and permanent kind of style of living on the landscape. So that brings us to a larger diet, a broader diet, one that includes more fish, and one that allows people to sort of settle down a little bit more on the landscape and stop moving around as much. What would cause people to do this? Why would people be motivated to make these decisions before ultimately migrating, at least in part, from this region? So there have been two hypotheses that have been proposed. The first is a volcanic eruption. So around 1,000 years ago, and you can see how this lines up really nicely with that migration event, there was a massive volcanic eruption, and I'll talk about the location and sort of ecological effects associated with that in a minute. but essentially a catastrophic volcanic event that propelled people to move out of this region. What I'll be considering also is a potential episode of population growth or demographic change. So this is a chart, and again, we're dealing with a lot of time here. So in years before present, where this is the present, this is the oldest occupations in Alaska, the earliest sites. And you can see there's a very large increase in the number of sites around 2,000 years ago. So again, this is very interesting in terms of that timing of that behavioral change. What would an increased population look like in terms of resource use and access on this really sparsely inhabited landscape? What would that look like? So these are basically the two factors that I'm going to consider today as having an effect on people's behavior and their ultimate movement from the region. So a volcanic eruption. I know this map is a little busy. I apologize. But I wanted to show you, this is the Mount Churchill, Mount Bona formation, which I know some of you are familiar with because you have an ice core from it, which is really cool. And I'd like to talk more about that. But this is the origin of two ashfall events that are both called White River ashes. The first one occurred around 1650 Cal BP, so around 1600 years ago, and was distributed mostly to the north. This hasn't really been associated with any major regional ecological changes. However, this event, which happened around 1150 Cal BP, which is around 1,100 years ago, distributed around 1 meter of ash in the area around, immediately surrounding the volcanic eruption itself, and ash actually as far away as Greenland. So this is a pretty significant ashfall event, which has been associated with not only a downturn, a decline in lake productivity throughout the region, but also a genetically documented caribou population bottleneck. So if you are wondering why would caribou care about ash, what does that have to do with anything? Well, the ash may have choked out the lichen in the region, thus leading to a major decrease in caribou populations. If you remember before, I said that caribou were a major subsistence, a keystone resource in this environment. And for those to disappear overnight, we can imagine that that would have catastrophic implications for the people in this region. So this is our first hypothesis. Alternatively, or maybe another hypothesis we could consider is a population-motivated behavioral change. So this data by itself doesn't mean that the populations grew, and I want to be really clear on that. Like, just because we have more archaeological sites during the last 2,000 years of Alaska's occupation does not mean that there were more people running around. But if there were more people running around, we can think about ways we might be able to track that and other lines of inference. So if there are more people on this environment, which, as I mentioned, has predictable resources that come in some amount of density, you can kind of map onto those resources like caribou. People organize themselves in caribou drive lines and other sort of ways of mass capturing caribou. Fish is another really predictable and dense resource, particularly salmon. So we can think about how populations might have responded to, these positive, dense resources and sort of started to grow, and especially during a relatively stable climatic interval, potentially they were allowed to sort of grow to their sort of operating capacity on this relatively marginal environment. So I've started talking a lot about resources, you may have noticed. These are some of the resources that you can find in Alaska. This is a really sad summer caribou. It was very hot in Alaska this summer, and this caribou was trying to get any piece of shade that he could. And in the summer, they're shedding, and they're not very nice to look at. But caribou and these other resources, this is a moose, and here's some fish. As I said, they're distributed at different densities, and particularly when we're thinking about an ecological collapse, that would have major ramifications for the distribution of resources on this already sort of marginal environment. So in order to think about resource distribution, first in an episode, a volcanic-induced episode of ecological downturn, we can think about how resources might become a lot less dense and a lot less predictable. On the other hand, if we have a population increase, potentially the resources are still dense and predictable on the landscape, but instead you're sort of competing with other groups for those dense and predictable resources, and you might start to make different decisions based on that. So in order to think about these more in depth, I developed a diet breadth model. So this is from human behavioral ecology, and essentially ranks resources based on their yield, so their return. Here I use caloric returns, and I'm happy to talk about this more if any of you are interested, versus their handling time. So how much energy does it take for you to get these resources versus how much energy you get in return. You can see blueberries over here are a very low ranked resource. They don't offer a lot of calories. They have some other benefits, which I can talk about too. But caribou are a very highly ranked resource in this environment. And what I want to know is basically when humans decided, or Athabascans specifically decided, that caribou were great, but we could also have some salmon too. Is it because caribou were no longer in the picture? So that salmon, if you began to, or and other fish, you began to invest in that resource, you could sort of take advantage of it. And in a resource, from human behavioral ecology models, we know that humans tend to pursue a more broad resource strategy when they are in periods of resource decline. So when resources are unpredictable, when they're sparse, a shotgun strategy to eating is usually what people do. Versus an environment where resources are dense and predictable, they usually specialize on certain resources. So this is what I'm going to be thinking about a lot today, telling the difference between a generalized subsistence strategy and a specialized subsistence strategy. What does that look like, and how can we find it in the past? So how can we find it in the past? Digging a lot of square holes. I talked to you guys a little bit earlier about digging square holes. I did 5 years of excavation at 4 different sites, and we dug a lot of square holes just like this one. We pulled out a variety of different artifacts. We pulled out remains from what people were eating. We pulled out pieces of the technology that people were using, and I'm going to be talking about those next. We analyzed those all in the lab. We also analyzed residue from cooking features, so places where people were actually cooking their food, and I'll talk about that as well. And then in addition to that, to sort of reference those materials within a broader context, I did a landscape analysis to compare what the individual findings I was finding at these sites look like in terms of the broader landscape in a multi-scalar approach. So let's just quickly look at what some of the predictions that I just talked about might look like in terms of these materials that I pulled out of the ground and the different data that we would see on the landscape. So this is, some of you may recognize the Mount Churchill-Mount Bona formation right here with the beautiful glacier in front of it. In the case of a volcanic eruption, we would really expect a shift to a very generalized economy that would no longer be dependent on caribou, probably at all. So that in terms of technology, we would expect them to be very maintainable and generalized. So things you would want to have a tool that you could use for hunting a moose and for fishing, things like that. So you would want sort of a Swiss Army knife approach. Things are good for everything. In terms of diet, again, a shotgun approach to eating. You would want to basically take whatever you could find, especially if resources are unpredictable. In terms of site patterning, we would expect to see an overall decrease in the number of upland sites, obviously, as that upland environment became relatively hostile with no more caribou around. And you would expect to see an increase in lowland sites and lowland site size. So sort of a switch to a different ecological setting. In contrast, if there was a population increase that led to these changes in diet breadth and mobility, we would expect to see increasing specialization in tools. Now you might think, why? Why wouldn't you just use a Swiss Army knife? Those are great tools. Well, in order to make it worth it to pursue fish all of the time, you need to decrease the handling time of fish. And one way to do that is by making a suite of technology that is specifically oriented around pursuing fish. And conversely, a specific set of technology that is specifically oriented around pursuing caribou. And that allows you to really sustain a larger population and generate a much more stable source of calories for yourself. And this is kind of how people think about the agricultural revolution as well. It's a way of sort of specializing in one thing, using a lot of technology to make something a little bit more predictable. In terms of diet, again, we would expect it to be specialized based on ecological situation. And then in terms of site patterning, we would expect to see increased site size in all locations and an increase in the number of sites in uplands and lowlands. And this increase in site size is based on the fact that people would be increasing their investment in these landscapes. So again, prolonged occupations with more people to harvest the resources that they would need to survive. So let's talk about technology a little bit more. Right, I know some of you, many of you, I'm not sure, may not know what kind of tools I'm talking about. So I have a pick, these are all tools that I found through my excavations. There's some more what we call informal tools. So these are some tools that you can see still the cortex, the outside of the rock. These are expedient, they're very quick to make. And usually these tools are used for scraping or as quick knives. And this is something I'll talk about a little bit more, but these are sort of quick and dirty tools that are good for a lot of things. These tools are bifaces. So we call them bifaces because they have two sides. And you can see here both sides of this biface. And these tools require a little bit more, there's a very complicated reduction strategy. They require a lot of forethought to kind of come through and execute this tool. And it's a multi-stage process. Now that tool is not as complex as this tool, which is called a microblade. These are all to scale, so these are tiny little things. They're about this big. They're kind of the size of razors. They're very small, they're very sharp, and you can socket these into antler to make a very efficient dart, or you can throw them with an atlatl. You can also use these as sort of fine carving tools. They're very useful implements, but they're very complicated to make. These are some of the microblade cores that I've had at my sites, and they're incredibly tedious to produce. So they're very, very refined technology. And then we have some copper up here, and I'm going to talk to you a little bit more about the role of copper during this transition too, but this is some of the earliest copper that we found in this central region. So I'm pretty excited about that. And then finally, we have some hide scrapers. These are kind of ubiquitous at all of the sites. I really like hide scrapers because this is one of the key technological links that we have to likely women in the archaeological record. So all of these tools could have been used by women, but these are almost certainly women's tools. So that's something that I really like to bring out. Usually you don't think about the individual too much in terms of these technologies. Okay, so I talked about sites. I excavated, as I said, at 4 sites. One of them had what we call 2 components. So it was occupied at 2 different times. You can see here. This is the present, and this is 2,000 years ago. And this is when that volcanic eruption happened. So I do have technology from before and after the volcanic eruption. And I also have technology from upland and lowland settings. And that's basically what I'm going to compare today. So I want to know how did tool production change throughout this transition period from 1,000 to 2,000 years ago? And are patterns different at different ecological zones? So is there a specialized reduction or use strategy going on at these 2 zones? Or is it more generalized, again, shotgun style? So what did I find? Here we have, basically, this is just showing the results of the material analysis that I did. So the types of tools people are using at these different sites. These are the upland sites, and these are the lowland sites. This is the one that was occupied after the White River ash. Unfortunately, I didn't quite get enough material to compare to all of the 4 other sites, just wouldn't be statistically very viable. But I did get enough material to compare the 2 upland and lowland sites. And you can see here, generally speaking, we see more core preparation, which is basically the first step in making a tool. It's also associated with those expedient tools, those quick and dirty tools that I was talking about before. And we also see a lot of early bifacial technology production here. So that's those sort of nice knives or spears that I showed you on the spear points that I showed you on the last slide. And to me, what this shows is that people are preparing hunting tools at these upland sites, and they're making a lot of quick and dirty tools at these lowland sites. They're also refining their knives at the lowland sites. So that's kind of an interesting thing too. And they're using a lot of microblades. So there are a bunch of interesting things going on in these data, just roughly here, and I'll show you the results of the statistical analysis in a second. And then this is my one homage to the University of Michigan. Sorry, everyone. So here you can see the distribution of exotic and local tools. So exotic technologies or exotic materials show that people are interacting with other groups in their region to get sort of the source. And you can see here at lowland sites, there are a lot more, relative to upland sites, there's a lot of exotic technology being used. And that's kind of interesting to think about why there might be more exotic technology at those lowland sites, and something I can't really speak to at this point. perhaps it's an aggregation spot. We know from ethnographic evidence and some oral histories that lowland sites did provide really nice gathering points for people to come in times in the fall and share resources, whether that be materials or information. So that might be something we could think about here. But this is also where I found these copper tools. So that's kind of interesting as well. And like I said, these are small, this is a small copper awl, and it could have been used for anything from potentially kind of needlework, poking, sewing, to tattooing, potentially, to medicinal uses. So again, this is really interesting technology to find, and I hope to recover more in the future. Okay, so the upland and the ecological zones are different in many ways, which speaks again more to specialization than to generalization. Upland sites had statistically more early biface production and microblades. So this is a reflection of a real specialization in that microblade technology here, and also early bifacial production. Conversely, lowland sites showed more expedient tools, exotics, and late stage bifacial reduction. So I ran a Fisher's exact test to calculate all of the statistical significance on this, and everything was of a p-value of 0.01 or less. And I'm happy to talk about the test that I use or anything else if you're interested in that at the end of the talk. But essentially, this is what I found. So again, this really suggests that these ecological zones are distinguishing somehow the technological production and use that's occurring in this landscape. Okay, so chemistry. Let's talk a little bit about chemistry. Here's another square hole. Some of you might notice that it's a little darker on this side. It's a relatively shallow hole. You can see it's pretty close to the surface. This is a 1,400-year-old hearth. So this is what a cooking feature looks like after 1,400 years. And it actually, we didn't get a lot of soil deposition here either, which is kind of interesting. This is a little scraper tool, like I was saying, you can use for preparing hides. And this is a little piece of birch bark that I found sort of laminated in the surface, this sort of this area of use. And the copper we found actually the following year right here. So this is a really interesting little sort of insight into the way that people were using this landform in the past. And so I wanted to show you this just to give you like a glimpse of, well, how do I know that it's a hearth or a cooking feature in the past? Part of that is the soil discoloration. So when I'm doing my sampling, I sample the darkest parts of these features, and then that's where I take my fats. I also sample off-site to compare those sort of subsistence-based data so that it's like a non-cultural soil. So essentially from my analysis, like I said, I recover those hearths and those off-site materials. I do fatty acid methyl ester extraction, which means I take the fat out. That preserves really well in this environment because we have very acidic soils. The acidic soils also mean that bones do not preserve very well. So this technique really helps us to identify subsistence patterns in settings where otherwise it would be impossible, which is really quite cool. And then I do gas chromatography mass spectrometry just to confirm the fats are there. And then I send it to the University of California, Davis, where they do a compound-specific isotopic analysis through gas chromatography, combustion, isotopic ratio mass spectrometry. So I know that's a lot of big words, but essentially all of this can get at what the dietary composition is using those cooking features. So what are people cooking? This is actually a more refined way of getting at what are people eating because it's in the cooking feature itself. And as opposed to a traditional analysis, which is just sort of like, what bone is this? You can get the relative contribution of different dietary sources much more clearly. And using that data, I want to figure out whether these sites and cooking features before and after the White River ash are different. So what is the composition? How much of it is fish or caribou? And how is it different before and after the White River ash? So these are some of my results. And here, I'd like you to focus on these colored shapes in the middle. I have, this is lake fish here. Here I have terrestrial mammals, and up here I have salmon. And these are based on previous studies using the same fatty acid methyl ester extraction and profiling modern animals in the area. These have been corrected for modern carbon in places. So you'll notice that this is comparing both delta C13 However, it's 2 different fatty acid chain lengths. So that's where it comes to this compound-specific analysis. So here you can see that all of my little circles are situated right here nicely between this lake fish and the terrestrial mammals. It doesn't really look like they're using very much salmon. That makes sense to me though, because all of these sites are next to lakes. They're close to lakes and not really close to salmon-bearing streams as far as we can tell. So this is kind of a nice illustration, but what does this mean in terms of, I told you before, relative contribution of different dietary items? Well, I did a Bayesian analysis using an R statistical package called SciR, which I'm happy to talk more about if you guys are interested. But essentially, this showed that at least 50% of the dietary input here was lake fish. So this is interesting too, because it seems like they're really focusing on lake fish, even though terrestrial mammals are a higher ranked resource and therefore should be more prevalent in these components. So this again is starting to suggest that at these lake sites, people are specializing on these lake resources rather than using a general shotgun approach to foraging that incorporates a lot of higher ranked resources like moose, for example. So all of these hearths have over 50% fish. Regrettably, I don't have any hearths from upland settings for this data set, and I hope to get some in the future, and I think that that would really fill out this data, but this is what it is, and it does show too consistency before and after the eruption. So Caribou Knob was occupied the earliest in the sequence and has the most similar results to this lower Klein site was actually occupied after the White River ash and almost 1,000 years later. So that's kind of interesting to think about too. We have this real continuity in behavior during this time period. So, all right, I've looked at sort of the nitty gritty, tiny little things on the lands, on these little site features. And now I want to bring it out into the broader landscape as a whole, the whole region, if you will, to expand it out. So I did a landscape analysis in GIS, and this incorporated data based on linguistic groups. So I essentially created a polygon based on all of these different language families of interior Na-Dene Athabascan speakers. And this is, again, very conventional in anthropology in the region to sort of identify these as being sort of homogeneous language-speaking groups in the past, based on that landscape data I was talking about before. From there, I basically dredged all the gray literature that I could, all the publicly available data on archaeological sites, and found all of the radiocarbon dated sites from within this region. I then calibrated those radiocarbon dates, and then I compared them in size and in relationship to lakes and rivers, because I wanted to identify whether or not people are using resources differently during this time period, not only in terms of the overall ecology, but also physical features. So this is the resulting map, and you saw this before. And I wanted to really try to identify how sites are different before and after the Athabascan transition around 2,000 years ago. So it could have taken a little bit more time, and it could have started earlier or later, but I really focused on 6,000 to 2,000 years ago versus 2,000 years ago to present. And then how are sites within that 2,000 years ago to present time period different before and after the White River ash? Is there a difference? And so what did I see? These are the sites that were occupied after 6,000 years ago until 2,000 years ago. And you can see that there are quite a few sites in the uplands, and that's reflected also in the majority of sites are in the uplands. And then here you can see the sites occupied after 2,000 years ago. And I'll flip back quickly. So you can see very much uplands. Here you can see a nice distribution of uplands and lowlands. And that's again reflected in the statistical data. So what I found in my broader data set, again through a variety of different comparisons between these time periods, was that after 2,000 years ago, upland site use remained consistent. So people are still using the uplands. However, upland sites are larger. So this again shows that they're doubling down on those upland resources. And further, there's this increased use of lowland sites in number and site size. So when I was talking about specialization in populations before, I was talking about how we would expect a real increase, like a fluorescence in all of these different ecological zones. And this is also interesting because these sites are closer to lakes as well, which indicates that people are really mapping onto that resource specifically and using it more consistently. Okay, so things are different after 2,000 years ago, but maybe this is all because of the volcanic eruption. Well, probably not. After 1,000 years ago, there's really no significant differences in my data, except that sites are closer to rivers. This could be for a variety of reasons. Perhaps the strategies people develop in these lakeside settings are so productive that they start harvesting salmon using the same strategies. Perhaps the White River ash did have an ecological effect that people took advantage of, increased productivity in riverine ecosystems. That's been associated with Mount St. Helens, actually, that sort of fertilizes the environment in some way. Or it could be, and this is hopefully not the case, but in Alaska we have a lot of meandering rivers. So you can imagine that the further and further you go back in time, the fewer and fewer river sites that you have, because the rivers just meander right through those sites. So that could be the case as well. However, you do notice some really big changes before and after 2,000 years ago, and that's really, I think, quite significant here. So where does that leave us? This is a nice tundra photo from the spot where my dad and I go caribou hunting every year, so just wanted to share that. And there's a nice lake here, so those lake and upland resources can be found in the same places, which is why I did the measurement versus those specific landmark features. So the evidence that I had, so these are the two predictions that I outlined before. And in terms of technology, I did see specialization based on ecological zone, and that was represented in the presence of exotics, but also specific kinds of tools. And that's that nice copper point that we saw before. In terms of diet, we did see a specialized diet based on ecological situation represented in those fish and hearth remains. And then finally, in terms of site patterning, we saw increases in overall site size in both the uplands and the lowlands, and the number of sites, just probably in the lowlands, not a significant increase in number of upland sites, but significantly closer to lakes as well. So this is really consistent with a population increase-based change in resource use. So I've been talking a lot about stones and dirt and all this other stuff, but I originally, in the title of my talk, did say migration. And some of you might be thinking, I thought we were going to talk about humans moving around on the landscape. And we are. So this is where we all kind of bring back together into the migration hypothesis. So what I found here is that Athabascans changed their behaviors in a more gradual way that is more consistent with a population increase or demographic change. And this is interesting to think about in terms of this very stochastic subarctic environment with a lot of temperature fluctuations and all kinds of other things changing all the time. It kind of makes sense that these people would be really resilient to rapid ecological change because they have a whole system that is set up to respond to rapid ecological change, being a very highly fluctuating environment. However, potentially in this environment, if you introduce different demographic factors or larger socio-political changes, it could be that disrupts human behavior a lot more than the environment does. And one thing that happens in the region at this time is the Thule emergence. So this is a huge group of warmongering people using metal tools that sort of bursts into the scene on the coast. And there are still lingering political tensions between coastal and interior peoples today. And I think that legacy may have begun as far ago as 2,000 years ago, and may be reflected in these behavioral changes that we're seeing here. So potentially people on the coast were displaced by the Thule emergence. Potentially Thule were trying to come into the interior. I'm not really sure, and that's something that I would like to develop a little bit more in my research. But it's interesting to think about when we're talking about human resilience and adaptation. The environment plays a huge role, but the environment that's forcing people into other people's space, maybe that is a more direct influence on people's behavior than the broader and especially rapid environmental change itself. And I think it's really important to think about this changing social dynamics in a situation of environmental change and instability as well. And I think there's also something that we can learn from the behavioral consistency that was present before 2,000 years ago. So these people were really well adapted to this environment, in part because of the robust social networks that they had developed. So thinking about how you can maintain a robust social network that is impervious to or resilient to environmental and particularly rapid environmental change is something that I think is possibly useful. So that brings me to kind of a conclusion here. So as I said, Athabascans seem resilient to rapid ecological shifts, but adapted to social changes. So it seems like social change in the region and demographic change was really what pushed the needle on this behavioral change and the ultimate migration event. And it's interesting to think about too, the oral histories Navajo have for their story of their emergence into the Southwest is based on social tensions that were occurring in the region that I study. So they suggest that incest was something that played a role in their leaving the past world and coming into the new world, the Southwest. So that's something I'd like to think more about too. Another thing I'd like to think about is whether or not hunter-gatherers are less sensitive to environmental shifts. So are non-agriculturalists a little bit better adapted to environmental change than we thought before? What does that mean for a lot of archaeologists who say, well, the climate changed, so humans changed their behavior? And that's a pretty common theme in archaeology today. And then finally, I want to think about how this connects to the earliest migration from the subarctic and the colonization of the Americas. So 15,000 years ago, people came into this area and spread south along a similar path. How can we connect the reasons for that original migration to this migration during the late Holocene? So these are kind of some of the things that I'm thinking about in terms of future research directions. But yeah, that's kind of the Athabascan migration. So thank you so much for coming, and thank you so much for having me. I hope that wasn't too much archaeology for everyone. I know that can get a little in the weeds at points. Do you have any questions for me? Yeah.
Based on placing
That's a great question. So we've done, a lot of anthropologists in the region have done this painstaking research to ask people throughout different communities to talk about different landforms. And some of the landforms, and one actually that's visible from a number of my sites, is called the Heart Among the Glaciers. And that's one of the key examples of this. That area has not been glaciated for 10,000 years. So for people to call that still Heart Among the Glaciers shows a sort of line inconsistency. There's more, I don't know, complex studies of landscape names that talk place names around prehistoric Lake Atna, which was dammed in by ice. And if you look at the way that they refer to different points on the landscape, you can tell that those place names come from a time when there was still water in that lake. So those are some of the ways that people have connected these kind of linguistic groups with people who are still there today. Yeah, great question.
You said they were the forerunners of the Hopi and Navajo.
Mm-hmm.
Did they make their way down there, 10 miles a year for hundreds of years, or was it a big migration all at once?
That's another great question. So I think it was a fairly rapid migration just based on the archaeological data that we have. And again, the sort of oral historic data that we have, our understanding of Navajo identity and things like that. And it really does seem like it happened over the course of maybe a few tens of years. So yeah, the genetic data we have could be better. And that's kind of more of an anchor in time, but it does seem like it was very fast. And so that's interesting to think about for the initial colonization of the Americas too, that people can move down that corridor really quickly. Although they did have a different social environment, obviously there were already people there during this migration.
Does anybody do any research over on the Siberian side to find out where they came from? I never read about that.
Oh yeah, there's actually a team of archaeologists who I work with at Texas A&M. They've done research over on the Siberian side to try to connect technologies, but also linguistic data between those two groups. And yes, there's definitely a linguistic connection. Athabascans and Navajo speakers have a lot of ties to Joktai, which is spoken over on the Siberian side. And so we know that ultimately the Athabascan language came from Siberia. Yeah.
I have a question about the topology. What made all the lakes? Why are there all those holes with water? And is the weather warm enough, like the Gulf Stream warms England, does the ocean keep the air warm enough to keep the water liquid instead of frozen? You got to have liquid water to fish.
Yes, yes. So it's actually quite hot in this region during the summer. It's we average during the summer months, gosh, I can't remember what it is in centigrade, but I mean, we had several weeks of 85 to 90 degree days. So they're definitely
2,000 years ago, was it still that hot?
Yep, it's been.
Why is it so hot? Is it from the ocean?
It's far away from the ocean, actually, is why. So it's sort of insulated. It's kind of like why the Midwest is so hot versus the coast. So they have kind of this weather systems kind of.
So in
get
other
stuck
words,
there.
it's really clear and the sun warms things up. It's a clear atmosphere all the time.
Yes.
What made all the holes for the water? How the lakes, why are there so many lakes?
There's a number of different factors, but some of them are ice dam lakes. So some of them still, there's like an ice dam that's kind of kept water from subsiding into the ground, although those are melting. So one of the sites that I work on, unfortunately, our cabin gets further and further away from the lake every year, and we have to haul our stuff further and further every year. And that's a big part of it. Glaciation has also done a number on the landscape. So those are
So it's
some
not
of the
craters,
factors.
it's not volcanic activity. Maybe.
There's a little bit of that, not as much in the region that I work in. Yeah, as far as I know. Other folks in the room might know more. Yeah.
I'm not going to take on that.
That's a big question.
Thank you so much for coming. It's really interesting to think about this in many different ways. I have a lot of questions, but I'm going to do two, and you can take your pick.
Yeah.
All right, so why is it unequivocal that women use the scrapers? And the other one is, I'm interested in the sort of coupling, so the human influence on the environment, and what evidence you have of that. Is there any comment? Well, you take it back.
Sure, yeah. So those are both great questions. Definitely not unequivocal that women are using the scrapers. And in fact, the way that people organize their sort of daily activities is very transparent. So that I think, when you live in this environment, which is so harsh, you really need to know how to do everything. Now, in terms of what we know from the ethnographic record, what people do today, ladies are definitely in charge of the hide working, and that's women's expertise. That's what they provide. So I think that especially there's like a cross-cultural consistency, pan-Arctic consistency, and so I feel pretty confident in saying that.
So it's like a modern analog?
Yes, it's ethnographic analogy for sure.
Yeah.
Grains of salt for sure. And it's not to say that, it's a little gender play, etc.
So
You had a second question.
I did, but I let you take a pick. If you want to take it on, that's great.
No, I'd love to. So there's a couple of different, I was actually talking at lunch a little bit about past fire maintenance regimes, so intentional burning that occurred. We know, at least through Wichin, we're using intentional burning as a way of managing their landscape. And I think that plays a role in the resurgence of forest fire activity that we see now. It's just like off the charts, crazy forest fire activity in this region. Another thing that I think about when I go caribou hunting every year is that the landscape where I caribou hunt is one that was used for 10,000 years by a group of people who was really set on caribou hunting and had a really good handle on it. And I wonder what that environment is like now in contrast to 5,000 years ago. I don't know. But yes, there's definitely a lot of human impacts on that environment. And then if you talk about like megafauna disappearance earlier, there's a lot of things going on there as
Did
well.
they manage to forage so they could have more caribou around? Is that the reason they didn't want a lot of things?
So
Why they did what they did? They were trying to attract them by managing what was growing.
yes, and it's also just makes a more navigable landscape. So when everything isn't totally overgrown, it's much easier to move around, and it's much easier to see the game on the landscape as well, not just caribou, but moose as well. Yeah.
So you have a population shift or increase that happens between 3 to 2 and then between 2 and 1 populations from your sites remain the same, right?
Yes.
So you're still left with the reason, the potential cause for the migration of 1,000, right? So they've been for 1,000 years. They were living in a denser population, occupying the lowland sides.
Yeah. So I think that it's a broad chronological interval for sure. And essentially what I'm trying to say here, we're not exactly sure when the migration took place. We know that people were in the Southwest by 1,000 years ago, but it may have started earlier. They may have gotten to the Southwest earlier as well. And so I think that these behavioral changes are intimately linked with that migration process. And so things had definitely seemed to kind of started to lock in around 2,000 years ago. But yeah, so that's
And there are proxies in their geological record for the social pressures you say that could have caused the migration as the fluid come in, for example.
yeah. So there's definitely, again, kind of like an ethnographic analogy case that you can make in terms of the way that coastal and interior peoples relate now that suggests that that tension has been building over the course of several thousand years or several hundred years. And so that's one way, but it's difficult because unlike in most regions, there's not a lot of culturally identifiable artifacts. So there's not a stone tool that I can pick up and I can say, this is an Athabascan spear, which is really complicated for archaeologists in this region. So we can't track, the Athabascan biface all the way down to the southwest. And so that's why I, bored you with all that theoretical stuff, because we have to use all the resources we can to get at those kind of identity questions. Yeah. Yeah.
I was wondering if there's any evidence of diets changing because the interior Alaskan range people were maybe trading or like learning from like the Inuit people who sand fishing or like the Meridian people.
Yeah. Yeah, so there's definitely, we in archaeology we'll call that a cultural transmission, sort of like people picking up behaviors from other people on the landscape. And that's definitely, especially in the case of those copper tools, one thing that I'll point out that another archaeologist showed me, I'm no copper expert, so I didn't notice this myself. So this is a piece of copper scrap, and there are a couple of different ways to make copper artifacts, but this is sort of like, you can see this is kind of cracked. This shows that people were not great at making copper artifacts. They weren't familiar with the process of cold hammering, so you heat up the copper and then you hammer it. They were just sort of striking it until they could kind of make it into something. So this has implications for where this copper came from and how people were learning how to interact with it, which is kind of speaking to what you're talking about. And we think that they did get it from coastal populations living a little bit closer to the source of this copper. In terms of salmon and fishing in general, we know people have been using fish at least from time to time for like 10,000 years. So it seems like they had that knowledge and they were just sort of saying, nah, we got this caribou, it's all good. But then around 2,000 years ago, it became really sort of a need to have situation, potentially. Yeah, that's a good question. There's definitely behaviors that were probably picked up in communication with other groups in the region, though.
So you talked about placement data. I was wondering, it seems like you use a lot of ecological history, and I was wondering how much like written and oral history you can use to kind of cite where you're going to excavate, or just how much you use in general.
That's a good question. So I don't use too much in terms of like, where will I excavate kind of information, but definitely in terms of when I'm thinking about the ways that people use the landscape, who are you going to ask? You're going to ask people who use the landscape. So I do read a lot of oral histories and ethnohistories to try to think more carefully about how people are using the resources on the landscape and what makes sense to them. Yeah, so I definitely try to glean that anthropological perspective on my research in that way. And oral historic data is tricky, right? Because there isn't a lot of good chronological markers, like I was saying before, but it can also help you to think a little bit more, bring you ideas you never would have had before, because you can only imagine so much, right? So that's kind of where I use that information as a way of sort of pushing myself to think more deeply and more earnestly about that record. Yeah. Yeah.
Did they have totem poles?
No.
What about their pottery? Did you find pottery? Did the pottery have symbols on it?
So we do have ceramics in the region. None of my sites had ceramics, and the ceramics we do have are pretty, they're pretty basic, and there's no marking on them or anything, and they're just, we do have a lot of good clay sources in the interior, and so they were just firing it up. Basically, they used whatever they could find as temper, and they made, sort of cleanware.
They were from Russia. The people inside their area had things like that. They had symbols, totem poles.
Sure.
They made geometric pictures of things, you know.
Well, so we do have,
What happened to people in Alaska? Why didn't they bring that with them?
well, there are, so southeastern and southwestern coastal Alaskans do have totem poles and longhouses and things like I think you're thinking of.
Oh.
In the interior, they had some of that symbolic, some of the symbolic artifacts, but a lot of them were made on things that don't preserve like wood. So maybe they had a lot more than we know about, is the short answer to that. One of the things that I think this copper all might have been used for is tattooing. It's something that's commonly used, and also potentially these microblades. Some of them have those kind of sharp edges. It's another symbolic behavior that's really common throughout North America. So something to think about. Again, I can't prove that, so yeah. Yeah.
I apologize, I spoke to this earlier, but I was wondering what you thought the reason for the population increase.
Oh, yeah. So it could be a couple of different things. That's a good question. It could be, like I was saying, potentially that population pressure squeezing more people into the interior. You know, if you have a really aggressive group of people as your next door neighbor, you might want to get further away from them, kind of thing. Or it could just be that this is a really nice, stable climatic interval, and populations are just sort of, you know, people had really honed in on the strategy for living on this landscape. It was stable and productive enough to support a larger and larger population, and sort of happened from there. Yeah, population increase is a really difficult thing to try to explain, though. So, good question.
Yeah, the Athabascan become caribou herders.
So, not in the same sense as Sami or other Arctic caribou hunters. They definitely maintained active caribou drive lines and things like that. So they weren't domesticating them in a full-on sense, but their relationship with the caribou was certainly a very close one. Yeah, but they weren't herding them on the landscape in that consistent annual way. They would sort of herd them along little paths every year and at the time we would hunt them. Yeah.
Did you think of pull factors instead of push factors for the migration?
Yes. So, I mean, I think the obvious pull factor is that more plentiful resources could be available in these, especially southern places. And thinking about, you know, the social networks that existed in the subarctic and Arctic were incredibly far-reaching. And it's clear to me that people, Athabascans, had an idea of what was out there beyond where they lived. So it's certainly possible that they were aware of the fact that there could be a desert environment that suited them better than this desert, you know? And also, if you have the tule breathing down your neck, maybe they wanted to move into a region where things were a little bit more friendly and weren't quite as hostile. Yeah. Golf, yeah.
With copper. Yeah.
They were tired of green, and they wanted to see more orange sand. Yeah, I don't know.
We have to look at any type of environmental potential factor away from.
It's just so far, like the immediate vicinity is so similar to what they've got right there that I don't know. Yeah, I haven't really thought about it too much. If there were a volcanic eruption that I think were more compelling, I would think about that more, you know, in terms of maybe there were caribou available over the next mountain range. But it doesn't really seem like that's going on. Yeah. And if you look more closely at the ecological data that we have that's been associated with that volcanic eruption, it's more kind of seems shaky as well. So that's another kind of an issue.
In terms of the ecological impact, wasn't it?
Yeah, and it was just as I was referencing Mount St. Helens, which is in a pretty similar in some ways ecosystem, it probably had very regional specific effects. So there were some regions that probably did have a lot of ash and probably were very disturbed. There were other regions that may not have been very disturbed. So yeah, I don't know. It requires more research. Yeah.
Did you find it even for the surfing activity?
Not in Central Alaska, none of my sites. They definitely were cold hammering at this site, or yeah, very much cold hammering because they weren't annealing it at all. On the coast, well, certainly the tule were smelting, they were making iron tools. And then I believe that some of the copper manufacture in the southeast was smelting, but I'm not positive. Yeah. question. We're just starting to use copper in the region at this time, so not quite there yet. White people hadn't showed up. Who knows what would have happened? Do you have any other questions or comments? Yes, questions have been great.
Thank you very much. And I know Bree was actually a collaborator on a proposal we put in last year, and she was courageous enough that when we called her for expertise, she accepted our cold call last fall and collaborated and helped us understand some of the landscape she was working in for some of the stuff we were intending to do up there. So this was a result of a conversation started a year ago by us just making an email correspondence. So,
I really,
thank you.
Yeah, thanks for emailing me.